Hi, this is Mrs. Sigala, and this is your homework 5.2. Okay, and for homework 5.2, we're working from mole to mass and mass to mole conversions. And so in order to be able to do these calculations, you'll need your calculator and you'll also need your periodic table of elements. All right, so in this case, the previous lesson was about molar mass, and we're going to be using molar mass as a conversion factor, as an equality, to be able to convert from mole to mass or mass to moles. And if you remember, molar mass has a unit of grams per mole. Okay, and again, we can switch this around, and it's the same thing as 1 mole over a certain amount of grams, depending on what formula or element you're working with. So let's look at our first one. Our given is asking us to convert 0.780. So I'm going to write down my given. Moles of calcium cyanide. So always make sure you write down your formula. Okay, calcium cyanide, and we're going to convert that to mass. And so in order for us to convert that, okay, we know that we want to get rid of mole. But in order to get to grams, we have to figure out this step. Okay. And this particular step, okay, right here, since we have grams per mole, which is the units, okay, we're going to have to figure out molar mass. Okay, so let me go ahead and do that. So again, to figure out molar mass, I'm going to have to use my periodic table of elements, and I'm going to separate my elements. Over here, calcium, I only have 1 calcium, and next I have carbon. Because of these parentheses, that means that you're going to distribute this subscript, so really I have 2 carbons, and I have 2 nitrogens. Okay, I look at my periodic table of elements, and it tells me that calcium's mass is going to be 40.078. Carbon is 12.011, and nitrogen is 14.007. Okay, and you're just gonna have to get used to writing quite a bit to make sure that your numbers make sense. And so even if you have to rewrite some numbers, just do that at the very beginning. In this case, I have 2 carbons, so 12.011 times 2 equals 24.022. And I know that a lot of students can do this type of math in their heads, and that's awesome. However, I always encourage my students to double check with the calculator, because even if I know the simple math as well, I tend to make mistakes. So 14.007 times 2 is 28.014. Now I'm going to add all 3. And I end up with 92.114. Again, we're working with molar mass, so my unit will be grams per mole. And I'm talking about calcium cyanide. Okay, so I make sure that in this case my number or my mass stays with my mass, so that's going to go in the numerator. Okay, next I'm going to use a different color so you can see what I'm going to be canceling out. Because I have moles in my numerator, it cancels out my moles in my denominator. I'm happy with grams because that's the unit I wanted to end up with. So I can put my equal sign now. So I'm going to multiply my numerators. So 92.114 times 0.780. And that's going to give me 92.114 times 71.848. Actually, it's 9. Okay, my unit that I'm left with is grams, and here we're talking about calcium cyanide. Next thing I want to look at is my given and how many significant figures my given has. So my given has 3 significant figures. Again, I always underline my first 3. I see how my doubtful digit is going to be affected, and in this case, because my doubtful digit is less than a 5, or I'm sorry, because the digit prior to my doubtful digit is a 4, it will not affect my answer, so my answer is 71.8 grams. And again, we're talking about calcium cyanide. And that's our final answer. Okay, next one is asking how many grams are in 0.50 moles of copper 2 sulfate. And so in this case, we have, 2 different things to figure out. The first thing that you want to look at is, we're being given the name of a compound rather than the actual formula. So if you remember from nomenclature, in this case, because we have this Roman numeral, it means we're working with a transition metal. Sulfate, again, that's a polyatomic ion. So we're going to crisscross everything except for covalent compounds. So I'm going to write down my copper first. So that's Cu. Because this Roman numeral is a 2, that means that copper's oxidation charge is going to be a positive 2. Okay. I go to sulfates, and I always get used to writing it in parentheses. Here's sulfates. I look at my polyatomic ion list, and sulfate's charge is negative 2. So I crisscross these to end up with Cu2, SO4, 2. But in this case, since they're the same subscript, we can cancel them out. So our formula remains as CuSO4. So now I'm going to write down my given. So my given is 0.50 moles of CuSO4. Now in this case, if you don't know your nomenclature, you can make a mistake on your formula, and that will affect your molar mass. Okay, so again, here we're going to end up with grams, so we want grams in our numerator. And we know that 1 mole of anything, okay, will equal the mass of that compound. So now again, because I have grams over mole or mole over gram, it means I have to calculate molar mass. And so again, I'm going to separate my elements. I have Cu, I only have 1. Sulfur, I only have 1. And oxygen, I have 4. My mass for copper is 63.546. Sulfur is 32.066. And oxygen is 15.999. Again, I don't mind rewriting them just to be on the safe side when I add them up. So this remains as 63.546, 32.066, because there's only 1 sulfur, but this one will change to 63.996. These are my decimal points. I'm going to add all these together. And that gives me 159.608 grams per mole. In this case, we're talking about copper sulfate. Again, this is the same thing as me writing 159.608 grams over 1 mole. And again, this little dash over here, this backslash, is the same thing as this bar. Okay, so now I plug in my mass, 159.608. Oh, and squeeze it in there. My moles, they cancel out. Okay, so 159.608 times 0.50 gives me 79.804. grams of copper sulfates. Again, I'm going to look at my significant figures. I have two significant figures, so I need to make sure that I stick with two significant figures. This 8 will affect my doubtful digit, so my answer would be, in this case, the only way to make it two significant figures is by writing it in scientific notation. I'm sure your teacher is going to be okay with you not having to do that. Okay, so okay, so 0.79804. Okay, and again, this becomes 8.0, in this case times 10 to the first power, and we're talking about copper sulfate. Okay, since my exponent is positive, that means I'm going to be moving my decimal point over to the right one place. Okay, but your teacher, again, I accepted 80, and I didn't have my students, in this case, apply scientific notation. Okay, next problem is asking us to convert 30 grams of silicone dihydrate to molecules. So again, dihydrate, that means that we're dealing with a covalent compound. Okay, so make sure you remember that. So we don't have to do any crisscrossing in this case. We can actually just write our answer. So my given is going to be 30 grams of silicone. Di means 2, hydrogen. Okay. So now that's my given, and I want to end up with moles. So since I want to end up with moles, I know that my grams will go in my denominator. And molar mass means that 1 mole of silicone dihydrate will be equal to a certain amount of grams of silicone and hydrogen. So again, my molar mass, my formula only has 1 silicone, and the mass of that is 28.086. I have 2 hydrogens. Each one has a mass of 1.008. Again, takes a little bit of extra work, but that's okay. I add these up. And I get 30.102, and since its molar mass is grams per mole, and we're talking about silicone dihydrate. Okay, so again, my mass stays with the grams, so it's 30.102. And now I can do my calculation. So again, my grams cancel out. I'm happy with moles, so I can write my equal sign. So if I were to write my fractions, I would end up with 30. Okay, and my surviving unit is mole of SiH2 over 30.102. There's no unit because we canceled it out. So when we divide those, 30 divided by 30.102, you end up with 0.996611. Okay, we can go on forever. Moles of silicone dihydrate. Again, I look at my significant figures, have one significant figure. And so to make this one significant figure, I look at 1. This 9 is affected by that 9. So this becomes 1 mole of silicone dihydrate, and that's my answer. Okay. Next one. Next question is asking how many moles are in 100 grams of potassium sulfide. So again, they give us potassium sulfide. It's up to you on how you choose to to work these, but I know that potassium, in this case I have an ionic compound because I'm dealing with potassium, which is in group 1, and sulfur, which is in group 16. So I have to look at their oxidation charges. Potassium's +1 and sulfur's a -2. Again, we have to make sure we crisscross these. So potassium sulfide is going to have the formula K2S. And again, remember, that must be accurate. Otherwise, your entire problem will be incorrect. Okay, so then how many moles in 100 grams? So 100 grams is my given. And we're talking about potassium sulfide. So I want to end up with moles. So I know that 1 mole of potassium sulfide is equal to a certain amount of grams of potassium sulfide. And so again, in this step, I need to figure out my conversion factor in order to get rid of grams. So I have to figure out my molar mass. I have 2 potassiums. I have 1 sulfur. So potassium, its mass is 39.098. I have 1 sulfur. I don't know why I put the parentheses there. Let me change my parentheses. I put parentheses on my number. And sulfur is 32.066. Okay, again, I'm going to be multiplying 39.098 times 2 gives me 78.196. I only have 1 sulfur, so I just transfer this number over. So I add them together. And my total is 110.262. Again, my unit will be grams per mole, and I'm talking about potassium sulfide. Okay, again, my gram stays with my grams. Okay, so 110.262 I look at my work. I can cancel out grams. I'm happy with moles, so now I can write my equal sign. So if I transfer my information over, okay, I'm going to have 100. My numerators, right? My only surviving unit is mole of potassium sulfide. And I'm going to divide that entire thing by my denominator, which is 110.262. Okay. When I divide that, I'm going to go ahead and continue working to my right. Okay, I end up with 0. And I usually like to write extra numbers and figure out my significant figures later. 0.90693. And I can stop there. Again, my unit is going to be moles of potassium sulfide. And in this case, it's another tricky one. My given has 1 significant figure. So then I look at my 1 significant figure. The 0 doesn't affect it, so my answer would be 0.9 moles of potassium sulfide. I have to make sure that's a capital K. And that's my final answer. All right, number 5. It says your grandfather has to take 5 grams of aspirin. I think we did this one in class for my classroom. And here's your formula for aspirin. Daily for his arthritis. How many moles should he take of this aspirin? So again, my given is 5 grams. And I'm going to write my formula, which is CHH8O4. All right, so I want to end up with moles. So moles is going to go in my numerator. 1 mole of C8H8O4. And that's going to be equal to a certain amount of grams of again, aspirin. So now we have to calculate the molar mass. So this one's going to be a little bit longer. Not too bad, I guess, but we have a carbon, we have hydrogen, and we have oxygen. Carbons, we have 8 carbons in this case. We know that each carbon has a mass of 12.011. Hydrogens, we have 8 hydrogens. Each one has a mass of 1.008. And sorry, I forgot to change the color on this one. We have 4 oxygens with a mass of 15.999. Okay, so now I'm going to do the math. I'm going to multiply these. So 12.011 times 8 gives me 96.088. One 1.008 times 8 gives me 8.064. And 15.999 times 4 gives me 63.996. Again, I'm going to add all these 3. And I end up with a molar mass of 168.148. My unit is grams per mole. And I'm talking about aspirin. Okay? Okay, so now I have to make sure I plug in that grams over in my formula, 168.148, and I can do my math. So again, my grams cancel out. I'm happy with moles, so I can put my equal sign. So if I multiply 5 times 1, because of my numerators, I'm going to end up with 5 moles of CHH4. And I'm going to divide all of that by, in this case, my denominator, which is 168.148. So 5 divided by 168.148. Again, it's going to give me 0.029735. And I'm going to stop 36 because it rounds it up. And I end up with moles of CHH4. Again, my last step is I want to look at my significant figures, and I see that I only have one significant figure, so really the only one that I should be looking at is this one right here. So how does this 9 affect this 2? It makes it a 3. So my final answer is 0.03 moles of aspirin, or CHH4. Alright, so now we have 6. Okay, we go to the pawn shop to buy your girlfriend some jewelry. Oh, you go, not we. The clerk offers to sell you a necklace that has 5 grams of gold in it for $300. How many moles really make up that gold necklace? Okay, and so again, our given is 5 grams of gold. Gold is by itself, so we know that the formula for gold, or the symbol, would be AU. So my given is 5 grams. Of gold. We want to figure out the moles, so again, we want to make sure that we get rid of grams, and that's going to equal 1 mole of gold. And again, we're going to require molar mass. In this case, we only have gold by itself, so we don't have to add anything up, because 1 atom of gold has, let me see if I can find that periodic table, 196.967. And let me split this over a little bit, like what I did. So again, gold's mass is 196.967 grams. That's how much 1 atom ways. So can we cancel out grams? And now I end up with 5 moles of gold over 196.967. So I divide that. And I end up with 0.02538 moles of gold. Again, I need to look at my number of significant figures, just one sig fig. So, look at this. This 5 changes this 2 into a 0.03 mole of gold. And that's my final answer. Alright, last problem. It says you're conducting a lab experiment to evaluate the reaction between calcium hydroxide and hydrochloric acid. Your teacher has told you how much of each reactant to use in moles, okay? And so that information is right over here. You must convert to mass before you can start. So complete the table and show work below the table. So again, here you have 2 givens, okay? So the first thing I want to do is let's figure out the formula of the compound. So again, we have calcium. We're going to do this together. Here's my symbol for calcium. And hydroxide, it's a polyatomic ion. So again, remember we have to do all this crisscross. Calcium's in group 2, so it has a charge of +2. Hydroxide has a charge of -1 as a polyatomic ion. We're going to crisscross these two, so we end up with CaOH2. Okay, next we're going to look at hydrochloric acid. Remember, it has a prefix of hydro, and so that means it's a binary acid. So all acids begin with the hydrogen. Chlor means chlorine. Hydrogen has a charge of +1. Chlorine, since it's found in group 7, has -1. We crisscross these. Nothing happens to our formula because it would cancel out anyway. And so our formula would be HCl. Alright, so now we're going to calculate the molar mass, for both. And so our molar mass for calcium hydroxide we have 1 calcium. And again, we're distributing this subscript. So there's 2 oxygens and 2 hydrogens. I'm going to make this smaller. Sorry, I'm taking up too much space. Okay, so I have calcium. I have 1. Oxygens, I have 2. Hydrogens, I have 2. Calcium's mass is 40.078. Oxygen, 15.999. And hydrogen is 1.008. Okay, I'm going to, here, calcium stays the same. Oxygen, 31.998. And hydrogen is 2.016. I'm going to add all these up. And it equals 74.092. Again, my unit is grams per mole. And I'm talking about calcium hydroxide. Okay, next I have hydrochloric acid. Has 1 hydrogen. Has 1 chlorine. And chlorine is 35.453. I add these up. they equal 36.461. Again, my unit is grams per mole, and I'm talking about HCl. All right, so I'm going to write those in my table. So molar mass for calcium hydroxide was 74.092. My unit is grams per mole. Talking about calcium hydroxide. My molar mass for hydrochloric acid is 36.461. Again, grams per mole. And we're talking about hydrochloric acid. Okay, so now, mass needed. So again, we're given moles. So now we have to set up our calculations. Okay, so we're not done yet. So again, our given in this case is 2.0 moles of calcium hydroxide. We want to end up with grams. We just calculate that molar mass, so we're good. So we know that 1 mole of calcium hydroxide, okay, we look at our molar mass, is equal to 74.092 grams of calcium hydroxide. We can cancel out our moles. Oh, we're happy with grams, so we can put our equal sign. Cancel out our moles. And again, we just multiply our numerators. So 2.0 times 74.092 gives me 148.184 grams of calcium hydroxide. Again, my given is 2.0, so it has two significant figures. So I look at my answer. Look at these two. This 8 affects this 4, and it changes it into a 5. So my final answer is 150 grams of calcium hydroxide. So I can write that down. I need 150 grams of calcium hydroxide. All right, so now I'm going to finish up with my last one. And again, my last one, they gave me 4 moles, 4.0 moles of hydrochloric acid. I already calculated the molar mass, so I know that 1 mole of HCl equals 36.461 grams of HCl. I'm happy with grams, so I can write my equal sign. I cancel out my moles, and I multiply my numerators. 4.0 times 36.461 gives me 145.844. Oops, sorry. 844 grams of HCl. But again, I'm given only 2 sig figs, so I need to make sure that I change my number to 2 sig figs. So I underline these 2. This 5 affects this 4 and makes it a 5, so I end up with 150 grams of hydrochloric acid. And that's it.